Hello everyone, I am Shubham Garg and welcome to this lecture. So in this lecture we are going to see the full guide to go from a schematic in SEdit from Tanner tools to a layout, that is in the Edit Tanner tool. Okay, so we will be making a schematic and then we will be converting that schematic into, then we will be performing DRC rule check and we will be performing extraction. So in this video I am going to show everything from the very basic, that is from the step of adding the libraries. So as you can see here, this is the SEdit open in my system, and now there are no designs, nothing. It is a blank SEdit window. So here I am going to add the libraries first, and then we are going to make a schematic of an inverter. Then we will be going to simulate it, then we will generate a symbol from that schematic, and then we will going to simulate that symbol, and then we will going to publish that symbol to the layout, and then we are going to perform DRC check on LED. Okay, so first of all, go to cell, create new view. Okay, so it is a blank window, so no designs exist. So first of all, go to file, new, and new library. Okay, so go to any location of your choice. So I am going to create a new location. Alright, Tanner, let's say I name it Tanner YT. Okay, and I am going to create a new folder, that is inverter. So I have chosen this location and I am going to click OK, and library name is this inverter. Okay, so I am going to click OK. So now you can see our inverter library is here. Now we need to add other libraries. So we need to click on add libraries, and now we need to browse and we need to go to documents. In the documents we will be having a folder, that is Tanner EDA. Here Tanner tools, here go into the process. Okay, there it is, generate 250 nm. Now we need generate 250 nm devices. Click OK and press OK. So you see generate 250 nm devices is there. Now again add other libraries as well. So after generate 250 nm, what we need is we need standard libraries. Okay, first one we need is miscellaneous. So I'm going to add this, and again I'm going to add some more libraries. First of all is spice plot. Yeah, so now it has been added, and now let's add another library, that is spice sources. Okay, so now we have all our libraries which we need to make the inverter. So this is how you are going to add libraries. Now after adding libraries, what you need to do is you need to go to cell and click on new view. Okay, so now remember in which library you want to create your cell. Okay, so we do not want to use the libraries which already have some devices or sources, because we will be using that for the components, for dragging and dropping the components in our schematic. So we will select the library which we have created, that is this inverter. Okay, and here we can name the cell as per our convenience. So we can name the cell as inverter. Now first we are going to make a schematic, so that's why make sure that view type is schematic. Alright, so now click OK and you will have your schematic window. Alright, so now let us quickly make a schematic of the inverter. So first of all we will search for a PMOS. Okay, here is this PMOS 25 and we are going to click instance. Okay, similarly now we are going to select NMOS and we are going to have an instance of NMOS as well. So here is the instance of NMOS. Now we will be selecting VDD. Okay, here is our VDD. Now finally the ground, and this is our ground. Okay, now we are going to use wire to connect both the gates, and there is our input. I am going to name the input as A. Okay, there's our output, and I'm going to name our output as Y. Okay, so now let us extend these a bit. Okay, now what you need to do, this is your schematic for inverter. Now what you need to do, you have specified the input port at A, but there is no sequence of the input at A. That is how the pulse or the voltage should be there. Okay, because after all, what we are supplying as an input, we are giving some voltage, right? So here we need to specify another source at A, that is V bit or V pulse or any kind of voltage. Okay, so I am going to select this V bit. So I am going to put an instance of V bit here. Okay, I am going to copy the ground here. Okay, and next thing what we need to do, we have used this symbol VDD, but the voltage, this DC voltage is nowhere defined. Okay, so we need to define a voltage, that is the power source, separately. So for that we are going to search for VDC. Okay, so here is our VDC, and I'm going to create an instance. So here I am going to place VDC. You can place this VDC anywhere. Okay, just connect this VDD, copy this VDD and paste it and connect it here and put a ground here. Okay, so our inverter is ready and I'm going to save it. Now I'm going to go to spice plot, and here I am going to select voltage print. Okay, so here this is the voltage print. I am going to take an instance. First I am going to paste it at the input. Next I am going to paste it at the output. Okay, if you are wondering how I am rotating it, it is by using R key. Alright, so I have put the print voltage at input and output so that we can see the input voltage, the input signal and output signal with respect to the input signal. Alright, so I'm going to save this. Now I'm going to set up the Tanner libraries and the simulation, the type of simulation which we are going to perform. So in this case we will be performing transient analysis. So first of all, go to setup and here click on spice simulation. Alright, in general tab here, this is the library files column, and just browse here. Okay, so here you need to go to documents, Tanner EDA, Tanner tools, process, generic 250nm. In the models folder you will find this generic 250nm file. Alright, so just open this file and at the end type space TT. Alright, so this step you need to do, otherwise the library file won't work. Now we have added the library file. Now just click here on transient analysis and here just give the stop time, let's say 1000 n for nanoseconds, and maximum time step, let's say I give it 10 n. Okay, so just click OK. Now save the schematic once more and click on start simulation. Okay, now we will wait for some time to see if the simulation is working or not, if we are getting waveform or not. So you see this tSpice file is generated and it is going to tell if everything is fine or not. So we got a waveform. We can see here that simulation completed, and this is WEdit, that is waveform viewer. Okay, so with this command, with this we can remove, we can separate the charts. Okay, so you can see it is working fine, that whenever one input is 1, the output is 0. Whenever the input is 0, the output is 1. So that's how an inverter is working. And if you are wondering why this pattern waveform is shown, this is because we have used the V bit. Okay, that is we use a V bit as the source, and let me just show you. So I am going to close this window. Let me just show you the pattern in our V bit. Okay, just a second. View properties. Yeah, you can see here in the V bit, this is the pattern. This is the pattern given, and we can obviously change it according to our need. So that's why that pattern of input was shown in the diagram. All right, so now this is our schematic and this is working perfectly fine. Now what we need to do is we need to remove the sprint voltage, okay, because and this as well, because we are going to move towards the symbol generation and we don't want print voltage to be there in our symbol. All right, so we will remove this, and you know what we can do, we can either leave these sources like this way here, or we cannot. It's our choice. Basically what will happen if we leave these sources, then they will be attached with a symbol, and when we generate the symbol doesn't need any external sources. Like in this case we have to define this source and this source, but we won't have to do so in the case of symbol if we generate symbol with this source. Otherwise if there are no sources here, then we need to define the sources in symbol. All right, so what I'm going to do, I'm going to leave the sources right like this way, and now what you need to do is you need to go to cell and click on generate symbol. Okay, so now in the generate symbol you will see this window will come, and just click on replace. So now you see here this is our symbol. Now don't get very excited yet, because this is just a symbol view, and what will happen if you try to move it, it will get distorted. I will just show you, but first you see in this inverter library, now you have two files. That is, one is the inverter schematic and the other one is view type as symbol. All right, so what we going to do is we are going to use the symbol. Now we can't use it here, okay, because this is a symbol view. To use it, what we need to do is we need to create a cell and new view. Okay, and now in the same library I'm going to name it as inv_sym. Okay, and I'm going to you need to change the view type as schematic. So once you do this, click OK. Now you see you have a new schematic here. Now you can use your symbol, and let me tell you how. Here is your symbol. You need to right click it and click on instance. Okay, like the way you do in all the other libraries. So that's how you are going to use this. This is your symbol, and click on instance, and you see here this is the instance of your symbol, and just paste it. All right, so now this is your symbol for the inverter. Let us put our ports. This is the input, and that's A, and that's Y. Okay, and we just need to put VDD ground. You see we don't need to put any sources, and that is only because we have already put the sources in our schematic. All right, otherwise we have to define the sources VDC and VBIT here as well. So we just need to connect VDD and ground. Okay, so this is our symbol. Now one more thing we need to do is we need to put the probes for the plot. Okay, because we have removed the probes from there. So I'm going to create an instance, and I'm going to place one at the input and other at the output. All right, so you can see here this is your inverter symbol, and this is your circuit. So now again we are going to do, first of all you need to check about the library files, okay, if these are available or not. You see, as I expected, the library file is not there because it is a new cell. Okay, so you need to browse and just select the library, and then you need to press space TT. All right, then go to transient analysis, stop time, let's say 1000N, step time will be 10N. Okay, click on OK, save it again, and now start simulation. So we will see if everything works fine or not. Let's see, simulation completed, and there it is. That's our inverter all over again. All right, see again the same bit, because we have already put bit in the sources in the schematic. so we don't need to put it in the symbol. All right, so you can see when the input is 1, the output is 0, and vice versa. So our symbol is working fine. Now let us close this. Okay, so now one more thing, again remove this print voltage. All right, now save it. Now what we need to do is we need to generate a tSpice file. Okay, so click this T icon that is open in tSpice. Remember this, now we are doing these steps to publish it to Ledit. Okay, that is we can make a layout. So for that you need to first create a tSpice file. Alright, basically at times you can directly publish without creating tSpice file as well, but you know this Spice Netlist file, what it will do, if somehow you lose your layout, it can help you recover that. Okay, so here this is our tSpice file. Now what you need to do is you need to remember this name, this subcircuit name, that is .subcircuit inverter. Alright, you need to remember this and just click on File, Save As. Now save it in the same location where you have saved your circuits. Okay, although you can save it in different location as well, it's totally your choice, but it is better to keep all the files in same location. So you can see this file will be saved as inv._sym.sp. Okay, so just save it and make sure you remember this subcircuit name, that is inverter. Also, if you forget, you can always refer this tSpice file. So I'm going to close it now. Now what you need to do after doing this, one, you can open Ledit in a new window and then load Netlist, or you can use this L button to publish it directly to SDL. Okay, that is Schematic Driven Layout, that will be directly published to Ledit. So if it works fine, then it will be directly published. Otherwise, if by chance it does not get published directly, then what we will do, we will load our Netlist. So let us see by clicking this button if it gets published directly or not. And you will see all the libraries of your design is here already. Alright, so now in this inverter, go to cell and create new. Now here you need to name the cell same as your subcircuit. Alright, so just give the name inverter and click OK. So you can see here you will get this kind of screen, this black screen, and once you get this black screen, you can see here in this SDL Navigator option, you have this option to load Netlist. Okay, that is open here and load Netlist. So just go to browse, okay, and click select your Spice file, that is inv_sym. So just click open, okay, and press OK. So you will see somewhere here, just zoom it. You have this structure of PMOS, that is the above one is PMOS and the below one is NMOS. Okay, that has been created from your schematic, that is from using the Spice file which you have saved. Your structure is created. Alright, so now we are going to see how to complete this layout, and then we are going to perform DRC and extraction. Okay, and I'm going to show you the steps for setting up the DRC and extraction as well. Okay, so now what we need to do, first of all we need to change their alignment. Alright, so there are many alignment options available. First we need to select these designs. See, now we have selected, all these options are enabled. Okay, that is align right, align horizontal centers, align center and all. So I am going to click this so that both the poly layer of both the transistors are aligned like this. Alright, so now I am going to create some more distance between them. So to move any layer, just select the area you want to move, press Alt key and move it. Alright, so this is how you move the area. Okay, so these are your ports which have been defined here from the netlist, but we are going to delete them. We will be defining our own ports. So first of all we are going to create this poly layer. Okay, so here is our poly layer. Now what you can do is either you can create either you can create a poly layer or you can extend it. So I am going to extend this. So just select this rectangle, place the rectangle here, press Alt key, and now, okay, yeah, sorry, not the rectangle, this arrow only. Place the arrow here, press Alt key, and you need to select this poly first to extend it, and I'm not able to select it. Let us move this layer. Okay, we can't make any changes since it is made through the netlist. Okay, so we can't make changes to this, so we will going to add a new poly layer. Alright, so just select this rectangle and here select layer palette. Okay, in layer palette you will find this poly, click on poly, and now just start making a poly layer by dragging your mouse. Alright, and press the down key because we need to go all the way to the below poly layer. Okay, and just leave it when you are done. Alright, so okay, it seems our orientation has been moved because we have been moving the designs a bit, so I'm going to undo it. Okay, and I'm going to select both the designs again, and I'm going to align it horizontally. Yeah, so now these are aligned, and now I'm going to use this rectangle, and I'm going to drag this poly to align with this one. Alright, so we have our poly. Alright, and now to see if our poly layer is fine or not, let us perform a DRC check. Alright, so here there is the option to run DRC. So we are going to run the DRC check, and you see no DRC errors. Now if you are running the DRC check for the first time, it will not run. It will say that DRC file is not provided. So for that you need to go to this setup Tanner DRC, and in the setup Tanner DRC you need to click on this, that is add command file to the list. Okay, so here from here you need to browse, and now you need to go to the documents, again Tanner EDA, Tanner tools, process, Generic 250 nm, and here this time you need to go to rules folder and just click on this caliber, and from here you will find this file Generic 250 nm underscore drc.cal. You need to select this file. Okay, so I have already selected this file. You can see Generic 250 nm underscore drc.cal. Once you select this file, click OK, and then your DRC check will run. Alright, so now let us do one thing. Let us connect the base with the substrate. Alright, so we are going to use a metal one layer. For that you can search here and you will find this metal one. Okay, so we are going to use this metal one to connect base with the substrate. Okay, now one important thing is that first of all let's save it and perform the DRC check to see okay, so all good this time, no DRC errors. Now one good thing is we can select the layer and copy it. So we can copy it by selecting the layer and we can paste it. Now use the Alt key to move the layer and connect these two base and substrates as well. Base and source, I mean. So these two are connected as well. Again save it and perform a DRC check. Okay, so far good, so good, no DRC errors. Now we have made the we have connected source and base. Now we need to connect both the drains. Alright, so again to connect the drains, use this metal layer and the rectangle, and from here just drag this all the way to the NMOS like this. Okay, so we have connected the drains. Again let us perform a DRC check. Basically I am just performing DRC check after every step to show you that our schematic is working fine, our layout is working fine. Okay, so DRC check is there. And now what we need to do is we need to state the ports. Alright, so for ports, now if you look at the schematic, let us see a schematic. Okay, so here is the schematic. You can see input is at gate, output is at both the drains, and VDD is at a source and ground is at a source. Alright, so here we are going to make the ports, that is using this option, box port. Alright, so using this option, first of all we are going to select here and just click OK, and we are going to name it as GND, that is for ground. Alright, so this is our ground. Now on this metal, okay, on metal you can make the ports directly. So we are going to name it Y because this is both the drains for the output. And here on this metal as well, we are going to make a port, that is VDD. Alright, so here we have these ports. Now to make a port for the input, that is to make a port on poly layer, what we need to do is we can't directly make a port on poly. We need to make first attach a poly contact. Alright, so you need to go to this square box, that is place via, this option. So when you click on place via, you will see there is this CNT underscore poly, that is poly contact. So now you need to click on OK for this poly contact. Okay, and you need to place it here. So now just save the design. Okay, let us save this first. Let's perform a DRC check. No DRC errors. And now let us have a poly contact again. I don't know why was that error. So here let's place it. Cannot save cell inverter view layout library inverter due to CNT polling missing from technology. Okay, due to some reason it is not taking a poly contact. Okay, no worries, we can make our own poly contact, no need to worry. There may be some issue in the library while exporting. So first of all we are going to delete this, and now we are going to go to poly layer. So we need to go to this poly layer and we are going to create it here. Okay, so we are going to overlap it a bit. Yeah. So here we have let's see, now to make a poly contact, what we need is we need a metal layer. So here we are going to take metal, okay, and we are going to insert it here. And now we are going to see a contact. Alright, so here we are going to make this contact. Yeah, so or we can even remove this metal layer as well. No, yeah, metal should be there. We have created a poly and metal and a contact. Alright, so let us check for DRC errors. So we will save it and we'll check for DRC errors. Okay, so there are some errors. So let us see. my god, it got closed. Anyway, no worries, we have saved all our designs, so somehow it got crashed. So I'm going to open the edit again so that I can directly open my design. Alright. So I'm going to go to file and open, and I'm going to go to our folder Tanner YT. So in this layout, and this inverter 2 was our layout. Okay, it is gone. Let's see if our layout is there in inverter. No. So no worries. We'll just publish it again. Yeah, so our design is recovered. That's great. So let's just save it, and now let's see if our design is working fine or not. So let us just perform a DRC check. So okay, it created the previous contacts. Okay, to remove this, it is just telling where are the DRC errors, so it is there in the ports. So just remove it from here, remove error mark. Alright, and now you need to remove these ports here, that is delete this, delete this, delete this, and delete this as well. So we are going to create our new ports, that is from here. So here I am going to name it as VDD, this I am going to name it as A, this will be my Y, and this is going to be ground. Alright, so let us save it and let's perform another DRC check and see, no DRC errors. Alright, so this is how you create a layout, okay, and perform the DRC check from SEdit. So now you need to save your design. Just press Ctrl S and you are done. Okay, so now next one more thing, that is the extraction. I am not going to go in the details of the extraction. I am just going to tell you how to set up the extraction. Alright, so from here you have the option setup Tanner extract. Alright, and again here you need to get this file, that is generic250nm.exe. So you need to go to again add command file to the list, click on these three dots. Alright, again go to documents, Tanner EDA, Tanner tools process, generic250nm, and here in the rules you will see a folder ext and you will have this file. Okay, so you need to select this file, and then after selecting that file press OK, and then you can go for extraction. Alright, so you see when you extract that you will get this ext file as the output. That is, it is going to read your design, what you have, what wires you have used, what layers you have used, okay, what things you have made in your circuit. You can see this N well, P well, substrate, poly layer, everything is in this extraction file. Okay, so I am going to save this file. So I am going to go, okay, so yeah, alright, it is read only, so I can't save it. Anyway, this is how you perform the extraction, and this is your final layout. So that's how you go from SEdit to create a symbol and then a layout in Tanner LED. So I hope the flow is clear, because at times the steps can be confusing, and that's why I made this video, to go towards a whole flow in a single video. Alright, so this is all for this video. See you guys in the next video.